Section 7.3, Special Products of Polynomials. Okay, our objective, this very first video, is we're going to use the square of a binomial pattern. It's important to know that we are talking about a pattern here. We are noticing a pattern and creating a shortcut for this pattern. Okay, so that is what we're doing in this section. These are strictly shortcuts that can make life a little easier when it comes to multiplying binomials. Again, remember, a binomial is a polynomial with two terms. Polynomial with two terms, two monomials. Okay, so first, we're going to notice a pattern here. So first, let's go ahead and let's start. Let's take x plus 3 times itself, times x plus 3. So we're going to go ahead and distribute here. X times x is x to the second. Plus, oh, forgot to take the x times the 3, plus x times the 3, which is 3x. Okay, plus this x times the 3, which is 3x. Plus the 3 times the 3, which is 9. Okay. So then this simplifies into, because these middle two are the same, 3x plus 3x, they're like terms. So this simplifies into x squared plus 6x, 3x plus 3x, plus 9. Okay. So if you notice here, we're multiplying something times itself. And mathematically, we're lazy. We don't want to write that times itself. So we actually have a shortcut way that we tend to write this. We tend to write it as x plus 3 to the second power, because we know something to the second power is really, it just times itself. Okay. Okay, so it's important to know that x plus 3 to the second is equal to x plus 3 times x plus 3. It is not equal to, does not equal, the reason I raise my voice is this is the most common mistake, it does not equal x squared plus 3 squared. Exponents are not distributive. I can't just distribute an exponent in. X plus 3 to the second means x plus 3 times x plus 3. And I then have to distribute it out, multiply it all out longhand. Okay, so here we go. Let's go ahead and let's look at another one. So here we have 3x minus 2 times 3x minus 2. So really what we're multiplying here is 3x minus 2 squared. So we need to distribute 3x times 3x. Well, 3 times 3 is 9. X times x is x to the second. 3x times the negative 2. Again, negative 2 plus a negative. 3x times the negative 2 is negative 6x. Okay. And then we have negative 2 times 3x is also negative 6x. And negative 2 times negative 2 is positive 4. So again, these middle two are like terms. We've got negative 6x, negative 6x. So when I put like terms together, I have 9x squared minus 12x plus 4. Okay? All right, just multiply. Okay. Let's go ahead and let's do another one. Here it's written as x plus 4. Oh no, my iPad froze. X plus 4 squared. So I will have to write that out twice. X plus 4 times x plus 4. And now multiply. Okay, oops, sorry. So x times x is x to the second, plus x times 4, 4x, plus 4 times x, 4x, plus 4 times 4, 16. Again, these two are the same, so I have two of them. So I have x squared plus 8x plus 16. All right, last one, and then we're going to look for some patterns. This is 5x minus 1 squared. So I'll need to take 5x minus 1 times itself. Take 5x times 5x. 5 times 5 is 25. X times x is x squared. 5x times negative 1. Again, plus a negative 1 plus a negative 1. That gives me negative 5x. Negative 1 times 5x is also negative 5x. And then negative 1 times negative 1 is positive 1. Again, these two are like terms, negative 5x, negative 5x. So I get 25x squared minus 10x plus 1. Okay, and now we're going to go looking for patterns. Hey, I'm going to kind of help you find the pattern here just to, for time. If you notice here, This original problem was x plus 4 squared. I'm going to jump to this one just because it's written as x plus 4 squared. This first term is what I get when I take this x times the x. This last term, the 16, is what I get when I take 4 times 4. Okay, well that kind of makes sense. Does that work for all of them? Here I'm multiplying x times x. Well, that gives me this first term, x squared. And then the 3 times the 3 gives me the 9. Yep, that worked. 3x times 3x is 9x squared. Negative 2 times negative 2, positive 4. Okay, that one worked. So that looks like a pretty consistent pattern. 5x, 5x, negative 1, positive 1. Okay, so far so good. But now we need to come up, where does this middle term come from? This middle guy. Okay, let's plug the 6. If you notice here, it comes from, here I got this 3x, which is what I get when I multiply the x times the 3. But then I get 2 of them. Okay, so I have 2 of those 3x's. Did that work for this next one? I took the 3x times the negative 2, which gave me that negative 6, and I've got 2 of them, which gives me the negative 12. Here, x times the 4, which is 4x. I've got 2 of them, which gives me the 8x. And then here, the 5x times the negative 1 gives me the negative 5, and I have 2 of them. So then we are able to come up with our shortcut. So here's our square of binomial shortcut. If I take something times itself, if I have a plus b squared, I get the first term by just taking the a times itself. So a times a, which is a squared. Oh, sorry. That was almost low. So the first one is a times a. The last one is b times b. The middle term is I take the a times the b. In all of these, I took the x times the 3 and then had 2 of them. So then it would be a times the b and a times the b. Okay, so our final shortcut rule is a plus b to the second is going to equal a times a, which we can shortcut that into a squared, plus 2 ab's. I've got 2 of them, so I'm going to write it as 2 ab's plus b to the second. Again, this is our shortcut rule right here that we can use to help us multiply these out without having to multiply them out all the way. Okay, so here's how the shortcut, using the shortcut would look. If you don't remember the shortcut, you can always write this out longhand. What I mean by that is if I don't remember the shortcut for this, I can take 3x plus 4 times itself and distribute. That's what this problem is asking me to do. Or I can use the shortcut and know that the first term is going to be this 3x times itself. 3x times 3x. So I would take this 3x times itself. I'm going to write it this way. The last term is going to take this 4 times itself. The middle term is going to be the multiplication of these two, but 2 of them. So I'm going to have 2 of the 3x's times 4. So 3x times 3x is 9x squared, because I have to square the 3 too, plus the 16 on the end from this guy. And then my middle term is the 3x times 4, which is 12x times 2, so 24x. So here I was able to get it without having to multiply the whole thing out. Just a shortcut. Okay. This next one, 5x minus 2y. First thing I'm going to do is rewrite it as plus a negative. And again, I'm going to use my shortcut. The first one I do is I square that first term. I take 5x times itself, which is 25x squared. And then I'm going to jump and do the last term. I take the negative 2y times itself. Negative 2y times negative 2y is positive 4y to the second. And then now the middle term, I multiply these 2 times themselves. So 5 times negative 2y is negative 10xy, because I've got to have the x, I've got to have the y. And then I need 2 of them, so it's going to be negative 20xy. So there's my shortcut. If you're not sure you did the shortcut right, I can always multiply this out longhand. Take this, times itself. Again, this is just a shortcut. If it doesn't work for you and you're not getting it right, don't use it. Okay. All right, so now I want you to do some practice. Page 375, 4 through 14, even. Good luck.